Hi, my name is Timothy Radel. I'm a professor of mathematics at the University of Houston downtown. Today I will be demonstrating how you can perform linear regression using the stat plot feature on the TI-83 or TI-84 graphing calculator. Here we have some data, and in this data we're trying to establish a correlation, linear correlation perhaps, between two variables. Here x represents hydrocarbon level, and y represents the purity of oxygen. Is y a function of x? Can we represent y as a function of x? Perhaps a linear correspondence. What I'd like to do is take the data for x and also for y that has been observed. We have 6 different observations here, and enter them into my calculator. First thing I'm going to do, however, is clear the RAM to erase any prior calculations. Now I can begin. First, I want to make sure that my stat plot is on. So I will go second and then the y equals button. This pulls up the stat plots. Right now, they are all off. I want to turn this first one on. I simply do that by hitting enter and then selecting, by hitting enter, the on feature. Now you'll notice there are different types of stat plots that we can create. I want to create a scatter plot of points, 6 different points, one for each data point. And so I'm going to use this first feature here. Other features have line graphs or histograms or box whisker plots and so forth. I want to put all of my x values in a list called L1, all of my y values in a list called L2. I'm going to use squares for those points that are going to be plotted, and I'll use the default color of blue. By scrolling down here, you can change any of these features, including the color. Now I am ready to enter my data. I will click on the Stat button, and now I want to edit by choosing option 1 under the Edit button. List 1 is going to have my x values. So let's enter those values. 0.99, enter. 1.02, 1.15, 1.29, 1.46, 1.36. Those are my x values, which represent level of hydrocarbons present. Now I'm going to scroll up to the top of list 2 and enter my corresponding y values. Percent of oxygen present. 90.01, 89.05, 91.43, 93.74, 96.73, and finally 94.45. I now have my lists L1 and L2. Now I am ready to perform linear regression. So I'm going to go to the Stat button again, and now I'm going to scroll over to Calc. And here's a bunch of the regression tests that you can perform. I want to perform linear regression option 4. So you can scroll down to option 4 or just hit the 4 button and then hit enter here. And now for linear regression, the slope will be given by the value of A, the y-intercept will be given by the value of B, and I want my x values to be in list 1, my y values to be from list 2. I want the calculator to graph the line, the best fitting line for this data. So I will store my regression equation that the calculator finds under the y equals menu, just like I'm graphing any linear or quadratic or any type of function. So for that, I'm going to click on the VARS for variables button. I'm going to scroll over to y variables, function option 1, and then put the regression function in function y1. Then scroll down to calculate and hit enter. It doesn't take very long to calculate a best fitting line. Now I'd like to see the points that are graphed as well as the line. And for that, I hit graph. Now, I don't see the points because my graphing window is not properly set up. So let me change my graphing window. Now, before doing that, take a look at my data. If I set a graphing window for x from 0 to 2, it will capture all of those x values. If I set my y range to go from, say, 85 to 100, it'll capture all the given y values. So let me change my graphing window by clicking Window here. And then we want it to go from 0 to 2, and then from 85 to 100. Now when I hit Graph, we see the 6 points that are plotted, and you can see that the data is not linear because those 6 points do not lie on a single line. However, we have graphed with this line. Again, it has now been placed here. Here is my slope, and here is my y-intercept. And so we have this best fitting line that we can now see on the graph. Linear regression is often used to help us predict y values given certain x values using the regression equation. Suppose I've got a hydrocarbon level of exactly 1%. According to that regression function, what would be the corresponding purity of oxygen? If I go to second and then the trace button indicating calc and hit option 1 for value, if I type in a given value of x, say x equals 1% hydrocarbon level, according to this linear regression function, the corresponding y value, the purity, would be around 89.36%, and there we see that point indicated with the cursor. Now, this data, as I mentioned before, is not linear. It's close to being linear. These points are close to the line, but they're not all on the line. Before, when we looked at the calculation of the regression line, we saw the A, we saw the B, but we did not see any measure of how good this linear regression function is. And for that, we need to go to Catalog. I'm going to do that now. Second, Catalog, and then scroll down to Diagnostic. And I want to turn my diagnostics on. Hit Enter. Now, when I repeat the test by going to Stat, Calc, Option 4, again, I will store my regression equation by going to VARS, and then YVARS, function 1, and then calculate. We now see some extra pieces of information here. We not only have our slope and our y-intercept of the linear regression line, but we also have an r-squared and an r value. R is the correlation coefficient, which tells you how close the data is to being linear. The value of r is always between -1 and 1. The closer the r value is to 1, the closer the data is to being linear. So this data is very close to being linear, as we see again when we look at the graph. Let me close this video by showing you an example of some data that is exactly linear. And so for that, what I'm going to do is clear my RAM again. Now I am going to go to Stat and enter some new data. So for this data, I am going to enter values of 1, 2, 3, 4, 5, 6 for x. For values of y, I'll use 4, 7, 10, 13, 16, 19. We know this data is linear because as the value of x goes up by a constant amount, the value of y is also going up by a constant amount. And so this data is linear. Now, let me set my graphing window so that you'll be able to see all of this data. Let me go from 0 to 10 and from 0 to 25. Remember to turn the stat plot on. Remember when I reset and cleared the RAM, it turned the stat plot off. So I'm going to turn the stat plot back on. It's the only change I'm going to make. And now I'm going to graph, and we see those points. Now I haven't done the linear regression yet, but I wanted you to see those 6 points plotted. They certainly do appear to lie in a straight line. To verify this, I'm going to perform the linear regression test. Stat, scroll over to Calc, Option 4, Linear Regression. I want to store the regression equation by going to Vars, scroll over to yVars, function y1, and now do a calculation. I don't have my diagnostics on, but we can see that the linear regression function is y equals 3x plus 1. It is a linear function. Now let me go ahead and put my diagnostics on again. Each time you reset or clear the RAM, you're setting everything back to its factory default. If you do reset or clear the RAM, you'll need to make the adjustments as necessary. I'm going to go to Catalog again by going second 0 and then scroll down to the D's and go to Diagnostics On. Select Diagnostics On. You can always turn them off if they're on, but I'm going to turn them on and then repeat the test with the given data. I'm going to store the linear regression equation, and I'm going to calculate. And now not only do I see that my linear regression function is y equals 3x plus 1, which I know is linear, the data is linear, and I have an R value of 1, which indicates perfect linear data. When I graph, I see that my line passes through all of the points, and my data is linear.